In this video, we analyze in depth the F4 error code, one of the most frequent in air conditioning systems of different brands and series. Its meaning is not universal. Each manufacturer assigns it a different interpretation depending on the system's architecture, the type of sensors incorporated, the software protection logic, and the way the electronic control board monitors operating conditions. For this reason, the F4 code may be related to fan failures, temperature sensor errors, EEPRM memory defects, or even communication problems between units. Below, we present a classification organized by groups of brands with equivalent meanings, which facilitates technical diagnostic guidance, followed by the most recommended procedures to detect and correct the fault in an orderly and safe manner. Group 1. Fan failure or blockage. Brands: Mitsubishi Electric, Hitachi, Haier, Tempstar. In this group of manufacturers, the F4 code usually indicates a blockage or a failure in the indoor fan motor. This condition appears when the control board detects that the motor is not rotating, rotates with difficulty, or presents abnormal electrical current. The causes can vary: dust accumulation in the bearings, stuck blades, a deteriorated start capacitor, or defects in the Hall speed sensor. Additionally, F4 may be associated with anomalies in the electronic board that regulates fan speed, such as a damaged triac or IPM motor control module, or interrupted tracks on the PCB. In some advanced models, this code also acts as a protection signal for motor overcurrent or startup circuit failure, which prevents the shaft from rotating properly. In these cases, the technician must check the motor's power supply, measure the resistance between its coils, and verify that the PWM control voltage varies correctly. If the fan attempts to start but stops, it could be a mechanical blockage or a defective Hall sensor. Group 2. Temperature sensor failure. Brands: Samsung, Panasonic, Gree, Sanyo, Trane, American Standard, Electrolux, Kelvinator, Bryant, Luxair, Rheem, GE, Frigidaire. In this second group, the F4 code is closely linked to temperature sensor faults, especially those related to coil, discharge, or pipe sensors. These sensors, generally of the NTC type, are responsible for reporting to the board the exact temperature at critical points of the system. When one of them becomes open, short-circuited, or its resistance value goes out of the expected range, the board stops receiving coherent data and triggers the F4 code to protect the compressor and stop operation. The causes may be due to sensors damaged by heat, broken wires, corroded connectors, or even errors in the analog-to-digital converter readings of the microcontroller. In some models, F4 is interpreted as an error in the outdoor coil or condenser sensor, while in other models it is associated with communication errors between the sensor and the PCB. Therefore, verifying these sensors with a multimeter on the kilo-ohm scale is essential, comparing the resistance obtained with the manufacturer's table at ambient temperature. A reading of 0 ohms or infinity resistance confirms that the sensor is shorted or open, respectively, and must be replaced. Group 3. EEPRM memory or PCB failure. Brands: Carrier, Medea, Bosch, York, Lennox, Goodman, Kelvinator, Nordyne or Frigidaire, Senville, Pioneer. In this group, the F4 code is mainly associated with EEPRM memory faults, a non-volatile memory that stores the equipment's internal parameters, calibration data, and factory values required for proper operation. When the EEPRM has damaged sectors, data corruption, or reading errors, the system cannot correctly access its basic configuration, generating the F4 code as an electronic error warning. In some models, F4 may alternate with codes E0 or EC51, indicating data loss, communication failure between the memory and the microcontroller, or an anomaly in the main board's programming. This situation may cause symptoms such as constantly changing codes, automatic restarts, erratic operation, or failure to power on. During diagnosis, it is advisable to measure the resistances associated with the EEPRM data bus, check solder joints, and verify the condition of voltage regulators and DC power supply filters, since poor power delivery can cause incorrect memory readings. If everything appears correct and the error persists, the EEPRM is most likely physically damaged or unprogrammed, requiring replacement with a new one containing the manufacturer's original data. Group 4. Communication or synchronization failure. Brands: Toshiba, Fujitsu, Whirlpool, Amana, Goodman, Lennox, Tempstar. In these systems, the F4 code refers to a communication failure between the indoor and outdoor units, preventing both boards from properly exchanging synchronization and control signals. The cause may be damaged wiring, loose connectors, oxidized contacts, or deteriorated electronic circuits. In many systems, the interruption of data exchange triggers the F4 code. Recommended technical procedure: A. System reset. Turn off and completely disconnect the unit. Wait a few minutes, then power it back on to force a microcontroller reset. B. Power supply verification. Measure the voltage between power lines. If instability or voltage drops are detected, install a voltage stabilizer. C. Connection inspection. Carefully check cables, connectors, and terminals, ensuring they are firm and free of corrosion. D. Signal voltage measurement. Set the multimeter to DC voltage scale. Measure between ports 2 and 3 or between signal wire and neutral. The signal wire voltage must fluctuate. It should not remain constant. E. PFC circuit inspection. Measure the output voltage of the rectifier bridge and check the fast recovery diode and IGBT transistor for shorts or leakage. F. Reactor verification. Measure its electrical continuity. It should be close to 0 ohms. If the reactor is open or has a high resistance, it must be replaced. G. Communication circuit check. Inspect optocouplers, resistors, diodes, and electrolytic capacitors that are part of the signal bus. Any altered component can break data synchronization between units.